Though it is not mentioned in any textbook that SJF is having any convoy effect, but then I'll give you some examples with which it will be very clear to say that, even in SJF also we have this, convoy effect. It happens this way. So if the process are all not available at the initial phase, then we are going to take the best one available, and now that best one might turn out to be the worst one later. Okay, instead of words, let me use the example. Let us say this is process number, and then arrival time, burst time. Okay, now process number is 1 2 3, right, and arrival time is, assume that arrival time is like this, 0 1 2, and burst times are, it is 20, it is 1, and it is 1. Now the same way, right, like the last one, in the last example the same thing is going to happen. So first one that will be picked up is at 0, time 0, I don't have any other option really. I have to pick only process P1, and it is going to finish at time 20, right? And next one that has to be picked up is by time 20, P2 and P3 are available, and both of them are having the same burst time. So remember that whenever two processes have same burst time, then we are going to pick up the one which has arrived early. So previously in FCFS we have seen that whenever two processes have the same arrival time, we have picked up the one which is having the least process ID, right? But here the tiebreaker is this one, arrival time. Therefore there is a tie here, right? Both the processes have the same burst time. Then in order to break it, you are going to take the one with the least arrival time, which is nothing but P2. P2 will be scheduled, which will run till 21, and then P3 will be scheduled, which will run till 22, right? So if you watch it, the completion times of P1 is 20 and P2 is 21, P3 is 23. Therefore the turnaround times are, I told you turnaround time is difference of these two, right? 20 and 21, and the waiting time is difference between turnaround time and burst time, 0, 19 and 20, right? Therefore average waiting time here is 39 divided by 3, isn't it? 39 divided by 3, which is I think 13. So average waiting time is 13. Now if I have given you the different example where instead of this, if this one arrived at the last, then you can definitely see that average waiting time is going to be fine, which means, okay, why don't you take that and see, let us say process number, the same process 1 2 and 3, but only difference is arrival time, burst time is same, 20, 1 and 1. Now the arrival time, instead of it is arriving at 0, let us say it arrived at a different time. It arrived at let us say time unit 2, and it arrived at 0, and it arrived at 0, right? Then what happens, the first one that will be chosen here in this case, if you draw the Gantt chart, can I write here? If you draw the Gantt chart, the first one that will be shown here is okay, the first one that will be chosen here is P2, because among these two burst times there is a tie, and the tiebreaker is arrival time. Arrival time is also same, right? Okay, then in this case it will be difficult. So let's say arrival times are different. Then P2, then what is it? They are at 0, and then it is 1. So at 1, what is that? At time 1 only P3 is available, therefore out of no option I will take only P3, right? I had no choice. And now here I can finally take P1 at time 2, which is going to take 22, right? Then you write the completion times. So completion time of P1 is 22, P2 is 1, and P3 is 2, right? If you observe one thing, completion time will always be greater than burst time, isn't it? Logical. The reason is, in order to complete a process, we need to finish the burst time, right? Completion time and burst time, the relationship will be completion time will be always greater than burst time, right? And as well as completion time will be always greater than arrival time, because a process cannot get finished before it arrives. Therefore completion time is always greater than burst time as well as arrival time. Now turnaround time is difference between these two, which is 20 here, 1 here, and 1 here, right? Then what is the waiting time? Waiting time is turnaround time minus burst time, which is 0, 0 and 0. So there is no waiting at all. No process is actually waiting. The reason is first P2 has been scheduled, then P1 has been scheduled, P3 has been scheduled as and when it arrived, and as and when it has arrived, P1 has been scheduled. There is no waiting time at all. So if this is the case, the waiting time, average waiting time is 0, right? So average waiting time of 0 might not prove some points here, but you could just make a small difference here, which is instead of having 0 and 1, you can leave them as 0, 0 and then pick P2 here and P1 here, then you'll get at least some waiting time. Anyway, what I mean to say is, see this, here the average waiting time is 13 and here the average waiting time is 1 for the same kind of schedule. Therefore, even this particular SJF is subject to a kind of convoy effect. I mean, I am observing it. If you are observing it, just understand it. Even though it is not mentioned, I feel that there is convoy effect, right? And second thing is, it is really not practical to implement it. So why is it not practical? First come first served is definitely practical. The reason is, every process will have arrival time which is definitely known before I schedule them. But here every process will have a burst time, but the problem is this burst time should be known prior to execution, but it is a very difficult thing. How can you know the time taken to execute a process before even executing it, right? That is the problem. Therefore, it is very difficult to implement this practically, SJF. So we don't really implement SJF practically. We just see what can I say? It is used for the performance measuring, which means it is used to compare against the other ones. It is going to give you the best performance in some cases. Now, what about the throughput? Throughput is number of processes that get finished per unit time. So here, if you see this, the total time taken is 22, right? So in this 22 units, I am able to finish 3 processes, right? Therefore, the number of processes which are finished per unit time is 3 by 22. And here also, in this 22, I finished 3. That is called throughput. Isn't it? So throughput is, you find out the total schedule, how much time did it take, in this total time, how many processes are you able to finish. That is called the throughput, right? So you can observe that, if you observe the previous one, that FCFS, right, and compare with others, SJF gives you the best throughput possible. The reason is, all the processes are going to get finished very fast, right? I mean, in the case, throughput, I don't know. Okay, fine, leave this point about throughput. I'll prove it later. Okay, so for now, fine, we shall take examples and see it. Don't worry about throughput at all. I'll tell you about it later.